Hello, everybody. Welcome to the Building Energy series. Today, from Calgary, Alberta, we have Grant Strem. He is the chairman and CEO with Proton Technologies. Proton Technologies is unlocking the clean energy economy. This is the second time we've had Grant on the show. And today we're excited to talk about more projects that they're developing and more initiatives that they're taking on to help decarbonize the economy, as that is a huge focus for a lot of the oil and gas sector and now even crossing over into the mining. Grant, welcome to the show again. Great to have you back.
Thanks very much. I'm happy to be here.
So just off the top, maybe just give a quick overview of Proton and maybe some of the new things that have happened in the last couple of years since you were last on.
Sure. Proton Technologies can make hydrogen from oil fields, old legacy oil fields, at extremely low cost and at a carbon intensity that's lower than zero. So this has become quite popular lately. Hydrogen can be used as a fuel, much like diesel, gasoline, natural gas. You can burn it in turbines or internal combustion engines. We can use it through fuel cells where we only have pure water out the tailpipe. And there's always, when the hydrogen is made, some energy that's needed to go into it. This is often associated historically with a pretty high CO2 footprint. So we bring some competitive value, not only because our cost structure is far lower, but also our carbon intensity is so much lower than zero. What's new? Last couple of years, since I've been on the show the last time, I think I filed one more patent subsequent to that, having to do mostly with crystallizing CO2 within the bottom water of oil and gas fields. So if you co-inject wastewater streams into a CO2 rich pore space, it will trigger reactions that CO2 becomes carbonate rock. That gives it additional hydrogen from the system while storing that extra CO2. We've sold some licenses in various parts of the world, a couple in the UK, one in Canada. Well, those are the larger ones to speak of anyway. And we're intending to open an office in Texas and
Oh,
another
great.
one in Europe.
Okay, fantastic. So a lot of expansion is happening right now. I want to go back to something you said as well because it sounded interesting. So the cost structure. So there was the basically before development at Proton. Can you get into a little bit more of that in more detail? I'm sure a lot of people would be interested in hearing a little bit more on that side of it.
Sure. So the way most hydrogen is made today, and I mean roughly 95%, they take methane or natural gas and they burn it and mix it with very high temperature steam. The steam gets hot by burning more natural gas. And you take all those ingredients and at a certain temperature, carbon monoxide, which is one of the byproducts, reacts with steam to produce CO2 and hydrogen. And then the hydrogen is separated from the CO2. And how it's done today in most of the globe, the CO2 is released to atmosphere and the hydrogen is kept for uses like making fertilizer or upgrading fuels. So the other main way to do it is also quite energy intensive. It's called electrolysis. That's most of the last 5%. And that's essentially electrocuting water. And on one you have a cathode and an anode, and on one side you end up with hydrogen bubbling out of the water, and on the other side you have pure oxygen bubbling out of the water. Water, of course, being H2O. So what happens with hydrogen as a fuel, whether it's through a fuel cell or through an engine, all you're really doing is recombining that hydrogen with oxygen, and that releases a tremendous amount of energy. So it pushes pistons or spins turbines or does whatever, releases electrons. So what we do, because it does take quite a lot of energy to separate that water molecule, the H2 from the O, we basically look at oil fields in a new way. So an oil field, when it's empty, is not actually empty. At the end of its economic life, it's generally still more than half full. So these are huge, well-known, well-established energy deposits that still contain most of their fuel. You just can never drain all of that excess oil between the rock grains to a production wellbore. But by contrast, it's easier for an oxygen molecule that you inject to go find those, trigger a reaction, and basically have productive hydrogen productive reactions happen. Then gases can be brought to the surface, keep the hydrogen, and re-inject the unwanted gases with the oxygen that's getting injected. So where does the oxygen come from? It comes from the air. So we have this massive 20% of our entire atmosphere is oxygen. So the scale of that is, unfathomably large, and we just take a little bit of that by cooling air to about minus 185. You end up with oxygen turning to a liquid. Most of air, roughly 80%, is nitrogen, and that stays as a gas at that temperature. So you get this cold oxygen, and then you warm it up, so it becomes a gas again separately,
Okay.
and then that's how you pressurize it to get it in the reservoir.
So your projects then you're actually able to use like these old oil and gas sites to start producing then. That's been the main, if I have that correctly, by cooling that off and pumping it into the old reservoirs then?
Exactly. So until these fuel deposits are all reacted, there's an enormous amount of well-known, well-concentrated energy that can be
Right.
released by adding the oxygen. So, and it all happens within nature's pressure vessel. So a geological seal is
Yep.
why that oil accumulated there. So we know that there's some sort of geological seal for the deposit to even originate. And then we do some assessment of that to make sure that it's solid and there won't be any escaping hot gases and that type of thing. Um, so yeah, that we use the oil field itself as the reaction vessel, and it comes preloaded with fuel for the life of the project, potentially a century.
Alrighty, so let's take a moment to thank our sponsors. First up, we have OptiSize. OptiSize is a leading edge geophysical acquisition design and software company. OptiSize provides innovative seismic survey designs utilizing the latest field technology and optimizing for advanced processing and quantitative interpretation techniques. OptiSize's mission is to bring sustainable exploration solutions to energy development with their custom land footprint reduction technology, EcoSize. EcoSize enables operators to focus on reducing their environmental and greenhouse gas footprint while imaging all their subsurface targets and reducing costs. You can visit them at optisize.com to learn more. We also have E3 Lithium. E3 Lithium is a lithium resource and technology company aiming to power the growing electrical revolution. Based in Alberta, E3 Lithium's combined resources, including the Clearwater project, are being developed on the backbone of the mature and sophisticated oil and gas industry that will allow the company to accelerate its development. Please visit e3lithium.ca to learn more. Next up is LNH. LNH Industrial can custom engineer and build from the ground up any heavy equipment assembly or machine that you need for your operation. Their worldwide 24/7 field services network is on the job whenever you need heavy equipment troubleshooting, repairs, rebuilds, relocations, or replacements. And thanks to their specialized design and engineering and state-of-the-art manufacturing and repair services, they are a go-to international supplier for improved components and custom assemblies for heavy industrial machinery. Visit lnh.net to learn more. We also have SolarSet. Introducing the SolarSet Fold, the new foldable frame solar system brings power to your residential and commercial property and can be shipped worldwide. Like all SolarSet products, the SolarSet Fold comes turnkey, pre-assembled, and is easily transported and installed. You can learn more about the SolarSet Fold and their full line of amazing solar systems at solarset.com. And last but not least, we have PowerZone equipment. When you need a specialized team of world-class engineers for your oil and gas pipelines, dewatering, or any fluid handling needs, you want to visit PowerZone.com. In addition to their inventory of rebuilt pumps, motors, and engines, they also have an amazing team to design and engineer your systems, no matter the challenge, no matter the location. Get in the zone with PowerZone. Visit them at PowerZone.com. And now let's get back to the interview.
On the other side, for the hydrogen, you have the system to capture it on the other end. Is
Exactly.
that
So
okay?
one of the advantages of using cryogenic distillation or cooling down the
Yeah.
air to separate it is now we have a way to do heat exchange with cold fluids from the air, and we can actually basically cool off the CO2 until it drops out as a liquid, and some other components like sulfur compounds or methane. We can just liquefy all those through passive heat exchange in different temperature at different temperature bands. So it's a
Okay.
massive energy savings in that way.
And on the hydrogen side, like just for capacity, how long can you be at one of these sites for? Like, is it a long-term process when you get set up at one of these fields?
Absolutely. So it really depends on the initial size of the field, the remaining fuel in place versus the rate of oxygen injection. So if you have
Okay.
a tiny field and a very significant oxygen injection rate, you'll use it up faster. But there are many enormous old oil fields that are mostly full of oil or were unsuitable for oil production in the first place. And
Right.
those, for example, our project in Saskatchewan, we think we can produce 1,000 tons per day hydrogen for 25 years. But if
Incredible.
we did 200 tons per day, then you're talking over 100 years.
Right. On that project, actually, I just pulled that up. The What is that in comparison, like for what does that do for energy for like the economy when you put that out into the market? Like, are people using it and buying it up as fast as they can get it now?
People are absolutely hungry for hydrogen. So there's a shortage of supply versus what the demand is. And by that,
Okay.
I don't mean niche, expensive markets for hydrogen. I think those will always be served. It's the base load electricity. For example, just using hydrogen to spin a turbine to power the grid. So as the electrical demand grows, a lot of that incremental power, I believe, is going to come from hydrogen fuel because we can make hydrogen cheaper than natural gas. It's an interesting opportunity. The same is true for baseload heating purposes. So refining metals, smelting things, or cement and steel, things that are very energy intensive and today use a lot of natural gas or coal can
Yeah.
instead use hydrogen. So, with the mining and refining industry, I think that there's an enormous transition underway, and it's going to happen quickly because hydrogen can be made cheaper than natural gas. And if there happens to be a carbon tax, it exacerbates the situation further and makes the advantage for
Right.
hydrogen that much greater.
Is this when you're doing this for the hydrogen? Does How does that work for carbon tax, or is that only on oil and gas? So then people are able to avoid that.
Our first example customer is Sask Power. So we'll be
Okay.
selling electricity directly to the grid,
Yeah.
and we plan to use a hydrogen compatible power generator. So if we're feeding it pure hydrogen, there is literally zero CO2 emissions in relation to that power production.
Right.
So we have no carbon tax if we have no carbon emissions. The other way that it can happen is if we grab additional sources of CO2, either from direct air capture or more likely from some industrial emitter nearby, we can get that into the ground and turn it into carbonate rock at a lower price point than the carbon tax. So we think that that will help sort of supercharge it. And again, CO2 turns to carbonate, which releases additional hydrogen. So in a way, it's kind of a CO2 to hydrogen play.
Okay.
So it can be carbon negative if we're grabbing outside sources of CO2 and sequestering them as rock, then the carbon intensity associated with that hydrogen can be far lower than zero. So if somebody buys that, whether
Yeah.
it's electricity or hydrogen or ammonia, at a negative carbon intensity, their whole portfolio can get to net zero with no other changes in their portfolio if they use our hydrogen.
So again, going back to these oil and gas sites, like of course there's many in Alberta, and then now of course in Saskatchewan, and then going down to the U.S. There's tons more. I presume. Um, so they would potentially these sites be able to bring in your system for all these older sites then, if there's the right amount of reserves still there.
Yes. So the amount of historic legacy fields and resources that weren't even developed is so vast it's hard to comprehend. So
Oh, okay.
yeah, we will never run out of resource, and nobody will corner the market on bad oil fields. It's vast. We are rate limited by how fast we can build surface equipment and get things installed and turned on.
Okay. And how going into a little bit more too of like you mentioned at the beginning, like some of the projects that you've signed on for, the what is the process now for starting to build up for Proton to get more of these sites in development and bring on more partners that want to implement this?
It depends on jurisdiction. So I guess there's three main ways we look at it. If somebody wants an offtake deal, the easiest is for them to just say, we agree to pay you a little less than what we would otherwise pay for natural gas if you supply hydrogen to us. And then we just go buy an oil field nearby and build our own project and supply it like a typical offtake deal. Some
Okay.
of them might be an oil and gas producer who says, we want to decarbonize our portfolio. So
Right.
we'd like to have a license to offset our own emissions or, have some other goals in the fuel space. So we'd like to buy something to take advantage of this legacy oil field. One thing it does is it postpones abandonment liabilities. So they might have some
Okay.
oil field that they don't want to abandon yet because it's expensive to, and it's inappropriate to if they can just simply repurpose it to hydrogen production and carbon sequestration. So we do sell licenses also.
Are you I just was wondering, are you able to go into like when you say like about a like to avoid that liability because they can put your system in place? Are you able to go into the cost structure at all and what something like that would look like?
Yeah, sure. There's three main types of oil fields you can buy.
Okay.
Um, there's if you just want to buy bulk barrels that are not good as oil fields and were not ever developed as oil fields, those are very inexpensive to acquire, but there's less certainty around the geological background of them, and there's less wells that you can repurpose. So if you find something that's approaching its economic limit where the abandonment liability is getting larger than its continued value as a productive asset, then that's a really appropriate time to convert it and start, um, looking at it in a new way. But they won't be throwing much cash flow during the construction phase. The other way is to buy a productive asset that more or less you buy it at a typical trading multiple, and it
Okay.
pays for itself from its own cash flow during the construction phase, and then you can pivot it at some point after that. If you want to, in some countries, we probably won't be producing any oil. Some places in Europe, for example, but in I think most typical cases, there will be some associated production of asphalt, for example. So if people like
Okay.
electric cars, they still like asphalt and rubber tires.
Yes.
Um, so there are carbon commodities that have to happen. I'm not a big believer in the very long-term future of liquid fuels market, but I do think that we will always be using carbon molecules for stuff like
And
asphalt.
that's one of when you said about the carbonate rock, I think you said for like a byproduct, can that be is that what you take essentially to use to make the asphalt and other byproducts? Is that where it starts as well?
No, that those still comes from the barrel of oil. So in some heavy
Oh,
oil
okay.
fields, for example,
Yeah.
yeah, we would basically take out the light ends, the shorter chain molecules, and the
Okay.
longer stuff is the asphalt that ends up in the roads. You
I see.
could design it different and make synthetic long chain hydrocarbons, but that's more expensive and complicated than is needed at this point in human history.
Okay. This sounds like energy independence is a big topic these days. The getting these in place where you're getting a whole bunch more lifespan out of these projects, like that one in Saskatchewan, you said you have it estimated for 25 years, is that right?
Correct. Yeah, for a
So,
thousand tons a day.
okay, so the amount of reserves that are in just taking Canada and just Alberta alone, frankly, the that would there's a huge potential. I guess you might have to have certain or no, but you're saying with the hydrogen, how I'm trying to ask this, you're going to actually produce a whole bunch more electricity as more and more people convert to the electric vehicles as well, right? Like you have the deal with Saskatchewan.
Yes, Sask Power. And to give a sense of like how much resource there is, our field has about 200 million barrels roughly in place. There's a deposit in Alberta that has 10,000 times more. There's a 2 trillion barrel deposit. So yeah, like I say, and that's different countries have different things, but there is more resource than we can conceive of ever producing within several generations.
So it's okay. So your outlook then, like say 1 to 5 years right now, what is what is that outlook for this? Like what are your kind of the goals that you've set for Proton going forward now?
We have a few near-term phases. The first is trucking in liquid oxygen. So right now we're injecting air and steam, and cyclically and doing our learnings in relation to hydrogen separation. The next phase will be trucking in liquid oxygen and injecting pure oxygen cyclically with steam again.
Okay.
And uh, in the background, we hope to be constructing our own air separation unit at site. It won't be a huge one, something that will only get to maybe 50 tons a day hydrogen,
Okay.
but it's something that sort of, instead of building a super huge project right out of the gates, I think there will be some useful learnings as we go through that first one. But we do have some scale up plans. And so this first site, we think, yeah, within 5 years, we expect to be around 1,000 tons a day or more. And
Okay.
there are many other sites, though, that we're looking into. As I mentioned, we're thinking about a Texas office. We've had conversations about offtake in Texas in the range of 7 or 8,000 tons a day. And that
Okay.
doesn't really do much to swing the local market, even just the electricity market, which is a deregulated market there as well as
Right.
Alberta, is quite large. So if you include shipping out ammonia through ports and blending with natural gas, the potential offtake is quite gigantic. So we want to do something pretty bit significant in Texas. We can
Right.
scale up a lot in Western Canada, and then the real pressure cooker, though, where the intense challenge is politically and economically, is in Europe right now. So with the situation going on there, there are reasons why energy security and food security are sort of front of mind in
Yeah.
several countries.
Yeah.
So we're trying to, well, yeah, we'd like to get some construction done quickly. I think, the politics and the economics are hugely supportive for that, and the
Is that
environmental performance.
yeah, is that the so I saw in some of the notes here when I was looking over it, you just made an announcement for is that a potential project over in the UK happening?
Yeah, that's one example. So there's a company called Clear Hydrogen UK that
Okay.
they've got a 5,000 tons per day license for hydrogen production and using our method.
I
And
see.
their concept is to do basically most of that from offshore in the UK North Sea. So on the scale of the geology, it's not that big, but on the
Hmm.
scale of taking off over or partnering with some platform operators and building some FPSOs, floating production offloading terminals, basically we can have a pretty meaningful pathfinder. I think 5,000 tons a day is enough to get attention. Ultimately, it will probably evolve to much more out of onshore and offshore. But it basically it's driven by where is the geology the most interesting in that
Right.
regard. And there's less onshore in the UK example.
Yeah, of course. The so this can be developed for those old offshore sites as well then?
Yes, yeah, that's uh, the plan for Clear Hydrogen UK.
Okay.
So yeah,
The how I don't know if you have the number off the top of your head, but what would make a significant impact in say Canada for like tons per day production using like this type of system?
to give a sense of scale, the Alberta power market is about 10 gigawatts.
Right.
If you're using a combined cycle turbine, you need about 1,000 tons a day to do 1 gigawatt. So
Okay.
um, if you include all the petrochemicals and fertilizer industry and things like that, I don't think probably 2 or 3 thousand would even register anyone's notice. So if you had a project that wanted to really transform the transportation infrastructure,
Yeah.
so heavy hauling and mining trucks and trains and that type of
Right.
stuff, and then Alberta could, as it got built out, approach 100,000 tons per day of hydrogen for relatively local use. Um, that's
Okay.
that's quite a bit, but yeah, it could absorb that, I think, and it'd be more productive. And it's a huge opportunity because right now the carbon footprint is roughly it's over 250 megatons per year of CO2. If you
Okay.
multiply that by $170 a ton carbon tax, that's a $40 billion drag on the Alberta economy just in carbon tax alone.
Right.
per
Right.
year. So
Right.
if you can instead have a carbon negative, so you're
Yep.
getting basically negative carbon tax, it's a huge opportunity to really, I guess, attract new industry if you do it big and fast. So
How does it getting into on because this is pretty fascinating and well, especially for me as I'm learning as you're kind of explaining it. Like, what do the competitors think, and what are the critics saying? Like, can you get into any of that fun stuff a little bit more?
I guess a lot of people at first when they hear about it, they're like, well, that's the lowest cost I've ever heard. So how can that be? And so there's an amount of skepticism. So some hydrogen expert who's been reading about methane reforming, I think the fundamental difference is there are very expensive input costs. If you're constantly buying natural gas to make your hydrogen, you've got a significant fuel cost throughout time. And then if you are trying to capture CO2 emissions, then that's another significant cost, and energy cost and complexity. So the cost structure of anything, no matter what, with full emissions, if you start with natural gas, do something energetic with it, and hydrogen comes out one side, that hydrogen will be more expensive on a per gigajoule basis than the incoming natural gas. So if
Right.
natural gas is your feedstock, you will never make hydrogen cheaper than natural gas.
Right.
So that takes pyrolysis and all these other ones like
Yeah.
totally off the table. For green hydrogen, it's the big input cost is electricity. So whether
Yes.
it comes from hydroelectric or geothermal or wind and solar or nuclear or whatever, you have a pretty significant electricity cost that never ceases. It's always this huge challenge to, supply enough electricity at a significantly low price point. And I haven't seen anything that makes me think that the cost structure will have really significantly dramatic improvements. It will continue to improve, but I can't imagine. So will our process. So if your cost structure is buy an old oil field, sometimes for $1. So if it's become somebody's
Right.
abandonment liability,
Yep.
you can't give them away. Literally, the government won't let you. Um, so yeah, you take over one of these and repurpose it. Your cost is dominated by the cost of an air separation unit, roughly 80% of the cost.
Okay.
So then, um, yeah, you have air and oxygen are in constant supply.
Of
The
course.
fuel is there for however long you plan it for, decades or a century or whatever.
Yep.
And so you're just bringing the two together and then separating out the hydrogen from the CO2. And the CO2 you're just locking in the ground as it goes. And then the hydrogen, you need to divert about 10 or 15% of that to power, like use it on site in a turbine to power the air separation unit. So the whole thing is disconnected from local electricity costs or power costs. It's just you use a little bit of your product to power, the further reactions. Ultimately, the unswept oil and gas and hydrocarbons throughout the system are what is providing the energy. So you're oxidizing a very significant, well-known energy resource in place. So what we typically do is we take oil out, transport it somewhere distant,
Yep.
refine it into some species or type of oil that can burn in a specific engine, gasoline or diesel or
Yes.
bunker fuel or whatever. And this, and then you transport it all the way back to some retail distribution center far away. All the while, the carbon is only adding mass and viscosity and inefficiency, and now environmental controversy and tax. So if you can avoid moving carbon atoms, you might
Hmm.
as well. It's far more efficient if you can, instead of oxidizing it while you carry it around in a car somewhere, if you
Yep.
can just oxidize it all in the ground and get it at large scale right at the source, and then convert it to something that's much more easy to transport, whether it's through power lines as
Yep.
electricity or
Yep.
through pipes as frictionless hydrogen, or not frictionless, but let's say far lower friction.
Actually, on the
Um,
electricity side, I may have not understood that completely. On the other side, when you get the hydrogen out at a site, you could you essentially set up like the power grid to go from that location for 25 years to produce power?
yes, yeah, we're already grid connected to Sask Power,
Oh, okay.
and we will be selling electricity. We have a 20-year PPA,
Oh,
for
okay.
example, and
Fantastic.
yeah, And the other thing is a lot of electricity goes to data centers. Those can also be co-located and
Yes.
also benefit from our cryogenic fluids if they have a bunch of cooling that's required.
So that could actually be like a new hub as more and more of these older sites get used. You could have data centers located nearby. And again, that it's basically removing all that carbon.
Yeah. And I think there's going to be a whole ecology that pops up. So if we have,
Yeah.
we announce 1,000 tons a day over here in New Mexico or something, there will
Yeah.
be some guy who wants, or gal who wants 5 tons a day for tire recycling, and somebody who wants 20 tons a day for microbial protein for livestock, and somebody who wants,
Mm-hmm.
their 50 tons a day for whatever it is that their hydrogen use case is. And so I think that's going to be something that, yeah, has these sort of um, ecosystems that build up around extremely low cost carbon negative hydrogen.
Yeah, that's going to be pretty exciting. I guess for like the big transport and like you said, focusing on that first, like the mine vehicles, the nice thing with them is they can actually be fueled with hydrogen easier, right? Than just your kind of modern day vehicle, from what my limited understanding.
Yeah, they can. So there's two ways. One is a blended system. So if you have a big diesel engine and you actually feed a little bit of hydrogen in with the air intake, you actually get more. It's a slightly hotter burn, so you get
Hmm.
more energy out of the diesel. So
Oh,
without even
interesting.
changing out significant amount of your fleet,
Yeah.
you can drop your fuel costs on diesel, clean up your
Okay.
emissions profile meaningfully, and yeah, the whole thing works really well for fast conversions of existing diesel generators and diesel, big rigs. If you end up with the next step or the next iteration, and there are far fewer of these, other than forklifts, there's I think something like 50,000 hydrogen fuel cell forklifts.
Oh, really? Okay.
Hydrogen fuel cells work quite differently, and they're being uh, tested and used in various you know construction equipment, mining equipment. I saw an announcement recently about a very large truck that runs on fuel cells. So basically the way a fuel cell works, they're more efficient. They just have like these tight membranes that at relatively modest temperatures are combining atmospheric oxygen with the hydrogen, and that releases some additional electrons, which gives you basically the electricity to drive electric motors. So it's more or less like an electric vehicle,
Okay.
but with onboard fuel cell and hydrogen tanks to power and trickle charge the battery and stuff like that. So
Oh,
those are
interesting.
getting quite popular as well.
So
In the long
the
run, they'll be more popular, but the quick
right.
shift is fuel blending.
And like you mentioned earlier, there's really no limit on how much capacity you could start producing in hydrogen either. It's just basically it sounds like we've got to build up a lot of the infrastructure.
Yeah. And that's part of the reason we're focused on baseload electricity, is because so much infrastructure already exists
Right.
electrically. So, but yes, if once we get to a point where we can't blend much more hydrogen safely into existing pipelines, natural gas pipelines, we'll be having to build, you know, hydrogen specific lines, and that'll be in some areas it's being tested, but it's
Okay.
not sort of in widespread use yet. When people realize that hydrogen can be made cheaper than natural gas, everything will accelerate. But
Right.
that's a long education curve for most of society.
Is that in part what you've been doing, like since we first had you on the show and since you first developed this? Has that been a big part of it, just to get more people on board with it slowly over the years as you do the education part?
Yeah, it's been somewhat haphazard. So we started, trying to be quiet about it all, and then we'll just slowly grow in the background and then come out someday.
Yeah.
And we sent a guy to a technical conference, and we had received almost no inquiries throughout the course of our time through our website. But the day
Yeah.
after an article came out related to this, we had 200 inquiries,
Amazing.
and about a third of them were investment related. So I thought, maybe we
Okay.
should rethink this staying
Yeah.
quiet idea.
Yeah.
So yeah, and now it's even for getting offtake deals, and yeah, as we advance, whether it's from an investment perspective, offtake, or even government awareness that this should
Yeah.
be in the roadmap,
Definitely.
the more we can increase awareness and education, that you can have hydrogen, clean hydrogen, cheaper than natural gas. That's something that is still working its way through the gears of,
Right.
the news needs to spread the good
Right.
news. So
Well, that's a lot of good information, Grant. Is there anything else that you wanted to touch on? Just anything we might have missed, or a question I may not have asked yet about like any of the recent developments or anything? This has been a lot of great information. I'm learning a ton just listening to it. So if I'll kind of leave it open to you if there's anything else that you want to touch on.
Well, I think one of the interesting ones is always, I keep bringing it up like a broken record. We spend trillions of dollars a year on, as a species, on solving like various wars and, warfare stuff.
Yep.
But if you look at what air
War killing.
pollution does, there's almost 10 million deaths per year from air pollution alone. And if we diverted just a small amount of, our collective resources as humanity into that, it'd be great, from the perspective of eradicating air pollution and the suffering and death that doesn't need to happen.
Right.
But in addition to that, there's also something to be said for if you can imagine a world where maybe we have 10 times the energy supply at 1/10 the cost or something like that. I think in the very distant future, we will approach ratios like that.
Yeah.
Imagine what we can do. Like right now, if you think of money as a sort of distillation of labor and effort and thought, it comes down to like we're spending roughly $10 trillion a year on energy. So
Right.
you can think of it like we're burning $10 trillion of human effort per year on energy. If we were instead diverting that to space programs or art or whatever,
Yeah.
imagine what humanity could do. So I think this is also something conceptually about sort of triggering a renaissance for humanity by collapsing the price of energy.
So that leads me to a question. That's why I wanted to ask that. So, like, essentially, with the hydrogen, it, if it becomes a boom, that can be produced after you get more of the infrastructure built at that much lower of a cost. You figure?
Yeah, definitely. So even now, if you look at, do I build a new coal-fired power plant or build a field of solar panels? I'm not aware of a lot of places in the world other than very unusual circumstances where people are choosing coal-fired power plants.
Right.
So once there's an economic tipping point, people will build the new thing. And that's one of the reasons, that is the main reason I think this technology will proliferate extremely quickly around the globe, is because the cost structure is so attractive. People
Yep.
will do all sorts of things to make a buck or save a buck.
Yeah.
They don't really care about the air pollution so much. They don't really care. They know smoking's bad, this and that. But if they can save a buck, buying a discount hot dog, they're all over it. So
Thank you,
even
Costco.
if they're a billionaire, yeah. Yeah.
Yeah, and for the developing nations, like it would be great to see more innovation that's happening like this, where that energy almost becomes a second thought as those economies continue to grow vastly. Like there's so much opportunity there.
Well said. Yeah, just the basics of like a school with electricity and heat or whatever.
Yeah.
Yeah.
And okay, well that's good. Any other final comments? I think we'll have where to find more information, who to connect with at your team, including yourself. That'd be great as well.
Sure. info@proton.energy. And our website is www.proton.energy.
Okay, thanks for sharing that. Everybody, if you want to learn more information, as Grant just gave those details, contact him anytime. Grant, thank you for coming on the show. Great to have you back on, and first time that we've got to do that I've got to interview you, so that's fantastic. But yeah, it's this exciting stuff coming in the future in the hydrogen.
Thank you. It's my pleasure to be here and talk about our company.
And to the audience, everybody, make sure you subscribe to the Building Energy series on YouTube. That is where you'll find this episode coming up. Also, you can follow us on LinkedIn, Facebook, all the other social media platforms, and